And then I can post these after the fact. That way I can record what I'm writing more easily. And I can write with this thing. All right, does somebody want to read the first one, and I'll try it using this tablet. You got the first one question? I guess I could pull it up here, but it'd be easier if you just read it. From the practice, from the first practice sheet. Do you guys have it up? Why don't you pull it up? Yes, yeah, in the box.
So if y varies directly with x, and x equals 9 when y equals 15, find y when x equals 33.
Okay, so y is going to vary with x. That means...
Do we need to write stuff for homework?
What's that?
Do we need to write stuff for homework, or like we're just doing?
I would definitely have like scratch paper and a notebook just to have some examples to look back on. You will have the videos to watch, but it might be easier just to look at your paper and remember what you were doing. So if y varies, yeah. Yes. I guess I can just switch here. Allison. Oops, wrong class, isn't it? Okay. So y varies directly with x, meaning if y varies directly, your equation is going to be of this form. Y is equal to some constant times x. An equivalent way of writing that is the ratio of y to x, when you divide them, will always make the same number no matter what the case. So this could be the height of an object versus its shadow length. Whatever the case, the ratio will be the same. Could you read those numbers one more time for me?
X equals 9 when y equals 15, and then find y when x equals 33.
33?
Yes.
Okay. So I'm just using the one on the left. Y is always going to equal a constant of proportionality, we call it, this k, and times x. Now they tell us that when x is 9, y will turn out to be 15. Okay, then there's another case when they say, well, what is x? I'll get to that. What is x when y is 33?
This is x is 33.
Oh, sorry.
Just find y.
So when x is 33, what is y? Well, just like before, when x was 9, y is going to be x times a number k. And in the first case, 9 times that number makes 15. So let's figure out what that number is. I want to solve for k. So all I have to do, hello Ryan? Hi. All I have to do is isolate k. What should I do? Not subtract. as a fraction?
Yeah.
Yeah, so we would say divide both sides by 9. Because when you have 9 and k by itself, right, like that, sitting next to each other, it means they're multiplied. So to undo the multiplication, we'll divide by 9. Then we can cancel the 9 on the right. And we see that k is equal to 15 over 9, which is also, 15 is 5 times 3. So I can cancel 3's there. So it is 5/3 or 5 to 3 ratio. The farmer should be happy. Well, I don't know. So they say we're really dry. Are you okay so far with this problem? Any questions? All right, so now we just used the first case when we knew x and y to figure out what that constant of proportionality was. That thing that's always going to be what we now know to be 5/3. We just found that. Well, now we have a new scenario. X is 33. Well, k will remain 5/3. So I'm going to rewrite this equation, but I now have that y is equal to 5/3 x. That's my new equation, because I just found k. So when I go to rewrite that, I will wonder what y is, but I'll know that k is 5/3, and that needs to multiply the new x to figure out what the new y is. Are you okay with what I just did there? Okay, so you always have the two situations. X and y are one thing before, and then they change, but their ratios will stay the same. 3 can cancel with 11 and 3, that make 33, so that'll leave an 11. And then times 5, y will be 55 in this case. Is that okay? We're on Google Classroom, Ryan. That first link for the practice problems, we just did problem 1. Questions on that one? You can check the answer. So we want to make sure we did that correctly. We did? Good. Any questions before we start the next one? What is the next question? Who wants to read number 2 for me?
If c varies directly as the square root of d, and c equals 14 when d equals 64, find c when d equals 324.
Okay. Would you just read the first to the first comma, I guess?
Okay. If c varies directly as the square root of d.
Okay, so that's what I wrote. C is on the left, and it varies directly with not d, but now they're saying the square root of d. what that means is that the ratio of c to the square root of d will be a common constant, will be a constant k. So just like before where I had y is equal to kx, here's a little different. C varies directly with the square root of d. So this is how I'd set it up. Okay? You guys okay with that? What was the first two set of numbers? What was C and D at the beginning?
C equals 14 when D equals 64.
Okay, so square root of 64 over here, 14 for the C. I want to find K. So that's all we got to plug in there. Who knows the square root of 64? Not 8. Oh yeah, it is 8. Oh, what am I thinking? I was thinking 16. Yeah, you're good. So K times 8 is equal to 14. Now what do I want to do? Divide both sides by 8. The 8s will cancel. I get K by itself. K is equal to, well, on the top that's 7 and 2 multiplied. On the bottom that's 4 and 2, so I can cancel 2's. So I can say 7 over 4. Is that okay? Okay, now we know K, so I can rewrite my equation as C is equal to 7/4 times the square root of D. So I just changed K in my original formula.
So then plug in 324 to the date.
Was that was the number was 324?
Yeah.
Okay, yeah. So I will write that again. Yeah, you're probably gonna need a calculator for that one.
Uh, 63 over 2.
You got it? Was that finished?
63 over 2.
Okay.
That's what it says the answer is 2.
Okay. So you had defined the square root of 324. I'm not sure what that is. And then a 2, I guess, would cancel. So 63 over 2?
Yeah.
Okay. So yeah, you just square root 324. Multiply that with 7. And then I guess you can't divide it fully by 4. You can divide it by 2. 2's will cancel, but then you'll have a 2 left over in the bottom.
I did not know how you just got to 64.
She did it on a calculator. I didn't.
I know, but like, what'd you do with the 7/4?
Can you?
I just plugged it into the calculator in 7/4 and then to the diameter of 324.
What's the square root of 324?
Yeah,
Can
that's
you,
like
can you guys do that?
what about 18?
18?
So would you just do 7/4 times 18?
Yeah. Times 18. 18 is 9 over 2, or 9 times 2. So all I can do is cancel a 2 here. And then you get 63 over 2. But I would have to spend some time figuring out 324 if I didn't have a calculator. Is that good? Let's try a few more from there. Let me delete this. If you have questions, just raise your hand.
cost of a pizza varies directly as the square of a 3.
Varies directly with the square.
Varies directly as the square of 3, yes.
All right. Well, that should make a lot of sense because the area of a circle is pi r squared. And they're saying that the cost of a pizza is basically associated with how much pizza you get, some constant times the radius squared. So pi will have to be in there, and then the cost per square inch will be in there too. So what are my two, how about somebody else? What are my two numbers in the before situation, before I know k?
You're gonna plug in 6 inches for radius.
Okay.
$8.
All right. So small 6-inch radius, so 12-inch wide pizza would be $8 here. And they're charging you for pizza. They're not changing the price, the profit purse at different sizes apparently. It's the same profit margin. All right, so I need 6 squared. Yeah. Oops, 336. Those are multiplied. And now,
Divide 8 by each side.
not 8. I want to get k alone. So the 36. That way, it's no longer on the right side with k. K is by itself. And that's your ratio over there. So I'm going to have to try to figure out what cancels. I know I can cancel a 2. You can cancel 4. Yeah, because 36 is 9 times 4. And 8 is 2 times 4. So the 4's can cancel, and I'll be left with, I'll write that. 8 is 4 times 2. And down here, it's 4 times 9. And that's k, so I can cancel the 4's. K is 2 9s. So my original formula will change. C is equal to 2 9s times the radius squared.
Plug in 11 or radius.
11. What was that? Oh. How do I do that? I have to project again. Okay. Sorry about that. We had found 2 9s for k. We put that into our same equation as before. Now the new radius is 11. So 11 squared is 121. If you double that, it's 242. I'll write those steps. So times 2 would be 242. And I don't think that can cancel. So that would be it in fraction form. I don't know what they have for the answer, but yeah.
They have $26.89.
$26.89. So if you
$6.89.
so if you divided these, hopefully it would round to that much. Good. Questions on that one? So hopefully you're seeing the pattern. It's always a quantity, it varies directly, meaning equals a constant times the other thing. That other thing might be a number, it might be the square root of a number, it might be the number squared. Eventually they'll get complicated on you and they'll say things like, the cost of a pizza varies with the radius and the height. So then you might have two numbers on the right along with k instead of just one, but it's just the same pattern. All right, somebody new want to read? Did you do the last one? Okay, yeah, go ahead then.
P varies directly as cube of Q.
Oh, they're using my k. So k varies directly with the cube of q. So I'm going to have to make up a new letter for this. I'll call it r for the common ratio. Okay.
And P equals 26.
Oh, did you say p, not k, or?
Yeah.
Oops, okay. Well, I'll leave it k then. This will be p. Perfect. Okay, say that last part again.
Do you want me to start from the beginning?
Yeah,
Yeah.
sure, yeah.
If P varies directly as cube of Q, and P equals 26, when Q equals 2, find P when Q equals 5.
Okay. So I've got my equation. 2 times 2 times 2. What is that? Up there, right? 8, yeah. And I'm dividing by what this time? Yeah, whatever's with the k. So k is 26/8. Honestly, you could put 26/8 in the other side of the problem and just multiply and divide it out and you'll get the right answer. But to simplify, if I divide by 2 on the top, I'll get 13. On the bottom, I get 4. So I think that's 13 is a prime. So that's as simple as it gets. Okay, we got k. That allows us to redraw or rewrite our equation. I now have p is equal to 13/4 q cubed. And I just got to plug in my numbers, or my new number, and solve for p.
Q equals 5.
Yeah, q equals 5. 5 cubed is 125.
Gracias.
Thank you.
And there's no real simplifying there. You're just going to have to kind of figure it out. So Yeah, it'll be big. It'll be a decimal too, right?
1,625 over 4.
Like that?
Yeah, that's what the answer is.
Okay,
That's what, plug it in.
nice. Just want a different color. Paintbrush. Do this color. I don't know. Who else wants to read one today? Uh, I guess let me show you. Well, let me not do that. Yeah, we'll just keep it the way that we're at. They could be a little trickier. So let me just show you that in case they do that. Let's say we had a relationship where y varies directly with, we'll just do x squared again. So that's our situation. Now, they might give you, I don't know if they would, but just in case they give you the constant, they might say if k is known to be 2, then, and they give you, let's say, x squared. I'm sorry, x is, what should I say? We'll say it's 4. So this time, k is one of the things you plug in. I don't know if they would ever give it to you like that, but in that case, you would square 4, you get 16, k would be 2, and then you would figure out what that y is. So you kind of figure out y instead, and you get 32. And really, then the problem's sort of done because you already have the constant. So I don't think they will give you ones like this. But then they could say, what happens when x is 6? So in that case, you might just plug in 6 here. You get twice 36. So that'd be 72. So it is possible that they might give you 2 different variables, but it's more than likely that they're going to ask you to find k first and then find the new y, or whatever that is.
Are we like not supposed to put parentheses in these kind of like problems?
You
Like
can,
around like that like squared?
it's equivalent. It's like when you have letters next to each other, it is assumed to be multiplication. That doesn't work when there's numbers. That looks like 123. But if I want to know that it's 1 times 2 times 3, I can do that. And if you want to do a little bit more writing, you can do that. These are all equivalent. A lot of times people will do the parentheses when they want to have a term that distributes over multiple terms or something. Or if they had an equation like ABC and they plug something in for B, then they'll show the parentheses to show that they kind of push something in at that point. But the dots in the parentheses are kind of equivalent. Just depends on what you think is more clear for the reader at that time. Usually with variables, we stick to one letter, so just writing them next to each other means they're getting multiplied. All right, I'm going to give you guys some time to try some more of the practice problems so that you guys can feel that you're comfortable. Remember that the second sheet of practice problems that I gave you starts with some text explanation, like what the videos show you. It starts with some text explanation of what direct variation is about. Then they'll have some example problems for direct variation. And then I think they'll have some practice problems for these, just like what we just looked at. I think at the very end of that packet, there are the answers for those practice problems too. So you can make sure that you're doing them right. And if you're not doing them right, then you can ask me what you're doing wrong. And then if you want to, you can already start on the assignment, see how that goes, see if it's different than what we just did, and let me know if I
Wait, so
should
we
have.
have another assignment due when we already have 2 assignments due Friday?
No, you only have one assignment due. I guess it'd be Friday.
Well, we have the ones that are in the book, and we have the one that's on with those 2 assignments.
Yeah, those ones that were in the book we walked through together, and I was just having you type out and submitting
Yeah,
those.
but we didn't end up finishing so what, and you said that was homework.
Okay, yeah, there shouldn't have been that many left. If you have questions on them, you can email me or see me after school. But this next homework assignment, I think it's 14 problems. They're all like this, I believe. So if you want to start those, now would be a good time. Any questions? Does this seem okay? Is that a no? Okay, well, let me know if you need anything. Why don't you take a look at those? And I should get you into that classroom.
Yes.